their entire Amazon service went down because so many people were shopping. So in this Christmas rush, 10 millions of requests, 3 million checkouts a day. And so this Amazon shopping cart application must handle many hundreds of thousands of concurrently active sessions. And they found out that every 100 milliseconds delay would decrease their sales by 1%. So 100 milliseconds, that's a almost imperceptible amount of time. But they measured it, they worked out how it affected their sales. And Google likewise did some experiments on how many hits you should return for a search. So originally, when you first did a Google search, you would get a larger number of hits in your top search, but it would take a slightly longer time to retrieve all of those. When they experimented with just returning the top 10 hits in your search in 400 milliseconds, and if they increased that to say return the top 30 hits in 900 milliseconds, so not quite, more than twice as long. This ended up decreasing their advertising revenue by 20%. So just that extra bit of weight that the customers were experiencing caused them to somehow attract less advertising revenue. And then likewise, when Google reduced the amount of mapping data that they transferred in a single block from 100 kilobytes down to just 70 to 80, this resulted in an increase in traffic of a quarter over a 3-week period. So just controlling how much data you transfer, caused people to use that much more. So it's surprising how much value there is in even tiny improvements in performance. So who are the major players in the cloud? I kind of track this each year. This is last year's data. I'll get updated data soon. Amazon is the biggest player in the cloud. They are bigger than the next three put together. So how did Amazon start? They built their reputation as a sort of online bookstore, and they needed a sort of massive infrastructure to process their orders. And as a result, they built up large numbers of computing servers to support the Amazon business, and then they discovered we might as well sell some of this infrastructure as a service to other people. The second player in the cloud, which has now leapfrogged ahead of Google, is Microsoft. They built a reputation for PC operating systems. They offer the best known general office products, and now they're shifting the same products into the cloud. And the main reason why they've suddenly become so big with Microsoft Azure is because the Azure products look very similar to the Office products that everyone was using on their standalone PCs. So it's a sort of easy migration route. IBM are the third biggest provider. They built a reputation for sort of corporate data services. And what IBM did was to optimize their own internal hardware as a private cloud. And now they sell, in addition to this public and private hybrid cloud offerings, they can build you a private cloud for your business if you want to keep your data secret. Remember, private cloud is a cloud that is where the hardware and the storage is all internal to your business. A public cloud is one which is shared publicly amongst multiple tenants. Google is the fourth now. It built a reputation with its very fast search engine, and they've expanded into data analytics and additional services. We call them freemium because the entry point is free, but when you want to do the more complicated stuff, you have to pay Google. So there's a premium and paid version and a free version, and they call this, they create this term freemium, a novel word, right? They offer a nice integrated platform, various components and APIs that plug together, which no doubt you've used. Salesforce is a company that you won't necessarily know, but they are the fifth largest cloud provider out there. Their market is software as a service. They pioneered sort of offering this via the internet. Initially, they just sold shrink-wrapped customer relationship management software. Then they offered it as a kind of web application, and now they've got a platform for generic software as a service. And they've joined forces with another provider called Heroku. So Heroku is now owned by Salesforce to provide the leading customer relationship management platform. And then Rackspace, that's one that you won't necessarily know. They built a reputation for hosting e-commerce websites. So they're well known in e-commerce business world, especially in the US. They became they developed themselves into the leading managed data center business. So their business they're all about managing data centers, and they're now the biggest sort of managed private cloud provider. So if you look at the growth of cloud over these periods, so Amazon increased its market share from 29 up to 34% in those years, and huge numbers of just 2.9 billion revenues just in the second quarter of 2017. Microsoft Azure increased from 9 to 11%, with 3 billion revenues in the same quarter. IBM only has 8% market share, but increased to 407 million. But its growth is sort of 57% compared to, so that's is growing by half as much every year. Microsoft is growing by as much again every year, so Microsoft is growing really fast. The Google Cloud Platform has a 5% market share, is still growing very fast, and earns those revenues. Then there are other sort of majors such as Rackspace, Salesforce, Alibaba, which is a Chinese cloud provider, Oracle, then the sort of telecoms companies. All together, they have a 27% market share, and that's that. So others here, that not mentioned here, also have a sort of 27% annual growth. So that's still a big growth factor. Here's the look at the back of the big four here. So Amazon, huge in 2016. Was that YOY is year-on-year growth. So from one year to the next year, measured as each quarter. So we measure the first quarter, sort of end of March, and the second quarter, end of June, and so on. And they compare that with the same period in the previous year, and so that gives you this figure. So you can see Amazon is by far the leading player, but Microsoft is growing really fast. Google is also growing really fast here, trying to catch up. And just in 2016, the world market in cloud computing grew by 51%. At the end of the year, we worked out that cloud had earned something like $28 billion for the various providers. Then if you move on to 2017, Amazon's gone up by 1%, Microsoft by 3%, IBM stayed where it was, Google's gone by 1%. The next 10 are losing out by 1%, and the rest of the market is falling way behind. So it's a kind of winner-takes-all scenario where the leaders are getting better and the trailers are struggling to keep up. Market share is now something like 34% for Amazon, 11% for Microsoft, 8% for IBM, 5% for Google. And when I get the 2018 figures, I'll update these slides. So that's how big it is. Segment leaders, infrastructure as a service, platform as a service are the biggest, with Amazon and Microsoft. Amazon Web Services, infrastructure, Amazon Elastic Compute, which is their platform, and Microsoft Azure, which is a platform as a service. Then hosted private cloud, IBM and Rackspace is quite big. But then other kinds of added value services, such as enterprise software as a service. Microsoft and Salesforce are very big at that. Here's a few other companies, RingCentral and cloud. And then what's this? This is infrastructure, hardware and software, public and private cloud. Well, Cisco, they're a sort of a router and switching company. And Dell is a previous computer company down there. And so there's all of these rates of growth and the sorts of products that seem to be leading. So the predictions made in 2017 for 2018 was we'd go up to something like 178 billion, which is equivalent to 22% compound annual growth rate, that sort of business type thing, and 50% of all enterprises rely on the cloud. We reckon that these three will have 80% of their revenue will be in the cloud by 2020. These three have 70% share of the software as a service market, and so far Kubernetes has won the war for container orchestration dominance. So containers are ways of packaging up an operating system, software, various applications that you want to run, and storing them so you can deploy all of that setup in one big go on your server. The Microsoft Azure stack has caused a huge jump in private and hybrid cloud spending as people move into the Microsoft world because they're familiar with it. And various cloud carriers, which are the telecoms companies, will ship 10% of traffic onto those. And various other companies like AT&T or Verizon will feel the pinch as various cloud carriers take over their traffic. So that's the picture where the world is going. And so we want to sort of say, well, why is this happening? Why is cloud taking off so much? Why is it so big? The reasons are kind of different depending on who you are. So if you look at a large corporation, they typically want to rationalize their internal capital resources. We'll explain what that means in a later slide. Whereas if you're a small or medium-sized enterprise, SME is a sort of European Union label for a company that has 200 or fewer employees. Okay, 200 or fewer is a small to medium enterprise. And these are typically, the dynamic new startup companies that the European Union likes to support because they are the potential engines of new growth in the economy. And these sorts of companies, they want to use the cloud because they don't know how fast they're going to grow, so they don't want to invest in large amounts of infrastructure up front until they know how much they're going to need. Then a different group of people, the big data people, who are wanting to research, do all sorts of research into data, they need increasing amounts of data storage as the data creation outpaces the rate at which they can analyze the data. So basically, they need storage. Then, how about this? Independent software vendors, ISVs. In the past, they sold ready-made software packages that you bought and you downloaded or you installed on your PC. But now they're wanting to piggyback onto much wider cloud-based markets for their products. If I can offer an application through the cloud to millions of users, then that's going to be better for me. And finally, small office or home office people, SOHOs, that's you and me, right? We're known as SOHOs in the business jargon. We are small or home office people, and basically we are interested in cloud because we want to access our work environment or social environment on the move. We want to keep in touch with all our friends, all our data, all our assignments, whatever else as we go. So let's break some of those down, looking at large corporations and see how this sort of motivated them to get into the cloud. The idea was they wanted to merge into, they migrated to shared cloud infrastructure. So if you think about this, a big company like IBM formerly, maintained a server room in every office basement. And so every branch of IBM had its own, collection of servers down in the basement, and so it would need technical staff to support and run that. They would consume power and so on. So the servers that they needed were expensive to buy and maintain, and they were often underutilized. So if you imagine you've got a lot of servers distributed in all the branches of your company, you might not be using any one server to anything like its full capacity, or maybe only once or twice a year will you be really driving that server to do what your business needs to do at certain pinch points during the year. So IBM thought it would be much, much better if we consolidated all the servers that we own in a few distributed data centers. So they took the servers out of all their offices, they put them into a few distributed data centers around the country, And then they offered company-wide access to all of those servers through an internal private cloud. So now that the way that you access your data is through the cloud, and the advantage is that you get much more efficient resource utilization and sharing. So this means you can run your company with fewer servers, and different branches of the company are taking different amounts or shares of those servers at different times as they need it. So you're optimizing your physical resource for your company's use. So you get a much fuller utilization of all of your servers, but it's because they're shared between your different company branches. We have had a guest IBM speaker who talked about this and explaining how much saving they made. The financial cost saving was really good. Also the power saving, because you only need to run fewer servers, so your electricity bills go down as well. What about this next group, small to medium-sized enterprises? So their reason for moving to the cloud is because they want to rent their cloud infrastructure or cloud platforms. And so formally, if you were a new company and needed some tech support behind it, the computing resources were a very large capital expenditure. You'd have to invest in some servers and some office computers and everything like this. And when the company is brand new, it's a great risk to buy when you don't know what the growth prospects for the business are going to be. They're hard to estimate. You don't know how fast or slow it's going to take for the company to launch itself. And then all the while you are expecting or hoping that the company's business will grow, the servers and everything else are expensive to maintain and update for the small business. So small companies can now mitigate this risk by renting compute servers and data storage in the public cloud. So rather than buying their own infrastructure, they choose to rent it, say, from Amazon or Microsoft. And then, of course, the pay-per-use model allows their infrastructure costs to scale with the growth of the business. So the notion is, if my business turnover is small, then my usage is going to be small, so I pay less. However, if my business suddenly grows in the next 12 months, then I can scale up how much resource I hire from Amazon or Microsoft, and that will just keep pace with the growth of the business. So you can see why that's attractive to small businesses. It mitigates risk, basically. That's why they're doing it. So for the large companies, it was cost savings and efficient utilization. For the small companies, it's mitigating risk. What about big data analytics? Well, the notion is that these folk, their main motivation is they want to rent cloud storage and rent processing power to help them deal with all of this huge amounts of data. And as you well know, we've seen recent advances in medicine through genome research or molecular biology, and all of these kinds of advanced medicine and other kinds of research generate vast volumes of data. I mean, huge amounts of data. A lot of it is actually very sensitive because it's related to particular people and individuals, so it needs to be managed and kept securely, and that's of course also an issue. And formally, the research advances that we wanted to make in these fields was blocked by inability to store sufficient data for later analysis. So some of the new findings come from analysing vast quantities of data and seeing patterns emerge in vast quantities. And another problem was the rate at which data is created by scientific experiments far outstrips the rate at which the researchers could actually analyse the results. And so this was a problem. It was blocking future progress in this field. So the idea of using a secure private cloud as a sort of data sink, this is the place where you can securely store all of your research data, all the results of your medical experiments and so on. And then this could be used as a sort of ongoing resource by the researchers who want to actually perform different kinds of analysis of this data. So that was the attraction. And in terms of the sort of processing power that they want, they can lease out high-performance computing grid nodes or even GPU-based processing clusters. This is the graphics processing unit on your computer, like the NVIDIA graphics card. The GPU chips can be diverted into performing massively parallel data computations instead. and so there's been a lot of exploitation of GPUs, rather like high-performance computing that we described as in the slides about grid computing yesterday. So a similar kind of idea. So this is the attraction of the cloud for these people. They can rent secure, private stuff there. Independent software vendors, their motivation is they want to push their product out onto public cloud platforms. So formerly they produced shrink-wrapped software packages. You may have heard of the jargon phrase shrink-wrapped. It means you buy a disk in a box with some install instructions and it's all wrapped up in cellophane, so they call it a shrink-wrapped product. It's just something that you buy, you install yourself on your PC, through your disk drive or something like that. And if you imagine, think back 10, 20 years, all software was delivered this way. You had to go down to a shop and buy it in a box, and then use the disk drive reader on your computer to upload and so on. So you would get your next version of Windows on a disk, or you would buy some application that you wanted. And of course, it was expensive for these providers to clone their software for all the alternative platforms, such as run it on Linux, run it on the Mac. There used to be Microsoft Windows for IBM PC, Microsoft Windows for Apple Mac. You had to have different versions, and then there was the constant upgrade cycle, so you had to constantly produce new media, print new media with new versions of the software. And the cloud platform offers a much broader target market, so basically anyone with an internet connection can access cloud resources, so that's a bit easier. And third-party software vendors can sort of piggyback on the success of popular cloud platforms. If you can provide a product that fills a hole in somebody else's platform offering, then that's going to work really well for you if that's a popular platform. So you can see that there's a reason why they only have to offer one copy of their software. It gets downloaded by everybody through the cloud, and independent software vendors get a sort of increasing value out of exploiting niche markets, so particular areas where their company produces the most famous kind of software for that particular niche or tiny specialist application. So that's the reason why ISVs are going for the cloud. What about people like ourselves, home users? Well, it's basically the attraction of accessing our digital world from anywhere. I guess you can't imagine what it was like not having Facebook and Dropbox and other things like this. Formerly we had to, 20 years ago, say, we had to buy shrink-wrap software to install. The operating system, the software required periodic upgrades, and our working and our social digital world was distributed over different machines. So we had some stuff on our home computer, some stuff on our work machines. And cloud platforms now offer kind of uniform access to your working and social digital world from anywhere. So the attraction is, accessing our data on the go. And if we use rented software rather than buying it, we always access the latest versions of that software automatically. We don't have to upgrade stuff anymore. So those are all the reasons to migrate. Or what about reasons not to migrate to the cloud? Okay, so we're going to have a look at what it is about the cloud that is driving people. And it turns out that the biggest lever, the biggest control that the cloud offers is to convert capital expenditure into operating expenditure. So these are reduced to those two little acronyms: CapEx for capital expenditure, OpEx for operational expenditure. Capital expenditure is where you have to buy your own machines, buy your own software and install it. Operational expenditure is where you just have to rent services. So basically the big thing that the cloud does is to convert CapEx into OpEx. And how do you choose? So how do you realize whether capital expenditure is going to be cheaper or operational expenditure is going to be cheaper? And it all depends on the pattern of resource consumption that you or your company has. So the costs of renting the cloud are directly dependent on 3, 4 possibly different measures. The first one is network bandwidth. How fast a network do you need? Data storage volumes, how much data do you need to store? And processing time, how much time of the CPUs on the machines are you going to occupy doing your task? and that the costs of the cloud are basically charged in terms of those few things. And the resources you'll require will depend on how frequently you need to access them and what your peak processing requirement is going to be. So if you have a big spike in huge amounts of processing that you need to do, then obviously that's going to cost more. So the question is how to work out whether the pattern of working with your business is going to mean that it's going to be cheaper to migrate to the cloud, or whether you'd be better just buying your own equipment. And so we did a feasibility study. So this is a little research project. David Newey, and he produced a nice bachelor's dissertation in 2014 called Head in the Clouds or Service in the Cloud. And he got hold of some cloud simulation software and set up some sort of realistic simulations. He looked at a micro-sized enterprise with about 10 employees, a small one with 50, a medium one with 400, and a very large corporation with 1,000 employees. So he set up those in the simulator. And then he looked at 6 different patterns of cloud usage. So he looked at companies that operated during peak working hours, so 9 to 5 only, and both with low amounts of traffic or high amounts of traffic. And then he looked at other kinds of businesses that operated 24 hours at a time, peaking in 9 to 5, but with low and high traffic. So that's 2 different versions. And then he looked at companies that were needed to do short but intense processing loads, again with low and high traffic. And here are some of the usage patterns that the simulator came out with. So I guess this is a 9 to 5 processing one with certain amounts of traffic going on. This is a sort of 24 hours type of load going on here. Here's something where we've got a sudden peak in traffic. Here's where we've got a sort of going all day company with a peak between sort of 9 to 5 working day. And he's computing the virtual machine cost, the data transfer cost, and various other total costs for this. And the simulation found that whereas for most combinations of business, it was actually cheaper to go to the cloud. There were just 1 or 2 where it was cheaper to buy your own hardware. So that was a really useful, interesting result. So here, if you've got an 8 hours per day business and then with high traffic, the difference between the sort of average server cost and the costs that you were running here were beneficial if you went to the cloud. If you were doing testing and development, you had low traffic or high traffic. Again, you got these differences. So sometimes the differences were large, 30, 40%. Sometimes the differences were small, just under 1%. But for these guys, when you had a sort of 24-hour-a-day operation and also high traffic blocks at that time, then it turned out that it was more expensive to run in the cloud. So that gives you some notion as to whether you should or shouldn't go into the cloud. And as part of this work, he surveyed a number of real business users in all of these different areas. And I was asking them, why do you think the cloud is going to be useful? So we got a whole selection of different responses, so we'll look at some of those. There was a man whose job was called capacity manager, and his chief reason was he wanted continuity. In the past, where they've been running their own systems, if their database went down, it would give them half an hour of downtime in their business while they were trying to fix it, and that cost many pounds. Another person in the role of senior project manager said, virtual data recovery, being able to get data back quickly was important. Software as a service was also important. Infrastructure project manager, so this is a man whose job is actually setting up the hardware for a company. He just went with the same finding that IBM had, which is consolidation of data services is good. It also saves operational expenditure, cheaper to run. lady who was senior application analyst architect. She said the cloud is flexible, and this is interesting, it's environmentally friendly. This is to do with the optimal use of the resource. So you're not spinning up and running servers for no good reason. But also worried a little bit about security. She said, no, the cloud is open to horizontal attacks, which are sort of insider attacks from stuff that's sort of in the same space. A service delivery manager said, was most concerned about security. Can we classify documents in different ways so that only the right people can access the documents that they have rights to see? Here's a few more. A service designer, so someone who's a bit of a sort of builder, says, increasingly we depend on more and more sophisticated IT, so the cloud software in principle can keep pace with that. Again, another infrastructure architect said, I found out that when I hosted remotely, it raised the re-provision time from 15 minutes to 3 weeks. So this person had a bad experience. He said not being in charge of my own infrastructure meant getting upgraded provision took much longer than I expected. So he preferred to keep his infrastructure in-house. Capacity manager, so to do with managing your resource. Again, consolidation of data and software services drives down cost. Another one, a continuity manager, someone who's there to make sure services are always available, said something like this. At the moment, my company is not well set up for the cloud. We get given a capital expenditure budget every year, which is fine, except software as a service and platform as a service have a high operational expenditure cost. So, I can't use my capital expenditure budget for this. So, again, that was a sort of business problem that he had. But then he said, flooding caused more damage than data corruption. So if they had flooding in their basement, that was a big problem. So it was a sort of one vote against cloud and one vote for the cloud. But the vote against was, of course, the problem that he had with the way his company financed himself. So to summarise all that we've covered today, the volumes of data being processed now are sort of astronomical, huge. There are a few companies that are well placed to deal with this mega scale, but I think you can see that it's clear how the various major players gained their prime position. Amazon got there because they had to build huge numbers of servers to deal with Black Friday. Okay, they had to build more and more and more servers to deal with Black Friday. And that meant that for the rest of the year, all those servers were lying idle. So they thought, how can we turn this into revenue? I know, let's sell servers, right? Let's rent out servers. So that's how how Amazon got there. And Microsoft got there through simply being the most popular kind of office product. IBM got there through being the most trusted business provider. Google got there through offering one of the earliest popular sort of online suites of software that people wanted to use, Gmail, Calendar, Google Drive, and so on. So it's clear that there are only a few players that are actually capable of doing this. And we've also seen then that the attractors that draw you into the cloud vary according to the type of business that you are. So, for example, big corporations have a different motivation from small to medium enterprises. And big data analytics even offers new kinds of business model. We offer you arbitrary grid compute power to deal with your massive data analytics problem. And you could rent it for as long as you want it, and that's fine. There's also scope for sort of software to gain a larger share of the cloud market as more people move there. And finally, we found out that the cloud suits many businesses, but not all businesses. So 24/7 operation may be more expensive in the cloud when you charge the operational expenditure than if you provide your own capital expenditure for a service. Okay, that's that. So that's I think the end of today's lecture. But again, I want to remind, I don't know if we got any fourth years. Again, please complete the National Student Survey this morning poll. It's commissioned by Hefke on behalf of all our funding bodies. It's nothing that we have anything to do with, so it's completely independent. It's supposed to be quick and easy to complete, and it means that we can see how the university has been judged at the end of the year. So again, thank you for considering that. So at 11 o'clock we will be in computer room 1, and it will be a tutorial on Linux for those who do not know how to use Linux. And remember, you can go here and you can download this tutorial here. I'm hoping that they've not changed anything since. We'll try this out. This will look like something like